Hey guys, Mr. Maz here for our advanced Pythagorean Theorem lesson. We're going to try to make this a little bit shorter this week because of not having school on Friday due to the Easter vacation. So there's basically, there's going to be three types of questions that you see on your ALEKS assignment. The first one that I'm showing here is trying to find the distance between A and B on a coordinate plane. And at first, you don't see a triangle, so you're wondering how is this related to the Pythagorean theorem. But if you take a look at going horizontally from A and vertically from B, now you've got your right triangle. And when they're trying to find the distance from A to B, remember all Pythagorean theorem problems, what we try to do is identify that right angle. So there's our right angle, meaning we have a leg here, and we have a leg here, and this turns into a missing hypotenuse problem to go from A to B. So we are looking at A squared plus B squared equals C squared, and we really just have to count the units. If I'm going to use this bottom leg as A, that is 2 units long. So I'm going to look at 2 squared. And if we look at this leg as B, that is 1, 2, 3, 4, 5. That is 6 units long. So we're looking at 2 squared plus 6 squared equals C squared for this particular problem. And then we just go through the math like we did earlier with the Pythagorean theorem. 2 squared is 4. 6 squared is 36. Remembering that squaring something does not mean multiply by 2. It means multiply that base number by itself. So we get 40 equals C squared. And as we all hopefully know at this point, we need to take the square root as our last step here to get the variable by itself. Now this particular question says round your answer to the nearest hundredth. When you have a number like 40, which is not a perfect square, so we're not going to have a whole number as our answer, there's going to be some rounding involved, so pay attention to how the question asks you to round it. So this says to the nearest hundredth. So the square root of 40 is 6.324 and then some change. But we look at that 4 to determine what should we do to the 2, which is in the hundreds place. And the 4 is less than 5, so we're going to keep it the same. So our answer here is 6.32. So moving on to this next question, it's actually very much related to what we just did, except now they are giving us coordinates. And they were kind enough to put this on the coordinate plane for us. Point P, you see, is negative 6, 9. So they went to the left 6 and up 9 to get to P. And Q is negative 2, positive 2. So they went to the left 2 and then up 2 from the origin to plot that point. Once again, they're asking for the distance between these 2 points. And there is no triangle. There's actually no segments at all right here. But we can make our own right triangle. It's going to be a little bit difficult for me to draw. That's not bad, though. So we're looking at the legs once again. We've identified, here's our right angle. So the 2 sides that make the right angle are the legs. And we can either count here, or we can go right to the coordinates that they have. If we're looking at going horizontally, all right, from left to right, that deals with the x-coordinates. All right, so our x-coordinates, all right, so x goes horizontally. So basically, we're going from negative 6 over to negative 2. And to go from negative 6 to negative 2, or the other way, it doesn't matter, that's going 4 units. All right, so this leg down here is 4. If we're going vertically, we're looking at the y coordinates. And our y coordinates are 2 and 9. So how far is it to go from 2 to 9? That also is 7 units here. All right, and you can do 9 minus 2 to figure that out, but the other leg is 7. So we've kind of identified this as a Pythagorean theorem problem because we're able to form a right triangle. It's once again missing the hypotenuse. So a squared plus b squared equals c squared. we are going to look at taking 4 squared plus 7 squared equals that c squared. And remember, 4 to the second power does not mean 4 times 2. It means 4 times 4. So that's 16 plus 49 equals c squared. 16 plus 49 gives us 65. And then the last thing we need to do once again is go ahead and take the square roots. So let me give myself a little bit of space here. The square root of 65, once again, is not a perfect square. So we're going to need to round again. And just like the last problem, we are looking at, it's saying round to the nearest hundredth. So we're going to need 2 decimal points here. The square root of 65 is about 8.06, and then the next digit is 2, so we can go ahead and stop at 8.06 because we do not have to round up. So 8.06 for the distance between P and Q. So this next problem steps up the level of difficulty quite significantly. We're looking at another Pythagorean theorem problem, but this type of problem, we need to apply the Pythagorean theorem repeatedly. Every other problem we've looked at up until this point, we only needed the Pythagorean theorem one time and one time only, but not these particular problems. First off, we need to check to see what the directions are even asking for. So it says use the information in the figure to find the length of SU. That's what we're trying to find. So we have S and we have U, which we notice is part of a right triangle here, the bigger right triangle. So we're in business here. We've got the right angle. So SU is a leg, RU is a leg, 70, RS there is the hypotenuse. But the issue here is we only have one part of the Pythagorean theorem, and we need at least 2 to find the missing side. So that's where the rigor gets stepped up a little bit here. But what you will notice is this smaller right triangle right here. This actually has 2 known sides to its right triangle, so we can use that triangle to figure out what this leg is right here. So let's go ahead and call that A. We know that A and 33 are the legs, so we're missing one of the legs. So we're going to go ahead and start with A squared plus 33 squared equals 65 squared. So this is really nothing new at this point. We've got A squared, 33 squared is 1,089. 65 squared is 4,225. And this is a problem where, since we are missing the leg and we're trying to get A by itself, we are going to subtract 1,089 from both sides here. So A squared equals 3,136. And our last step here is to take the square root of A squared. But what I'm going to have us do here, I'm not actually going to figure out what the square root of 3,136 is. I'm just going to leave it like that. And you'll see why here in a minute, because I know that we're going to be using this in the Pythagorean theorem again. And what we really need to recognize is that squaring and taking the square root of something are inverse relationships here that are going to really work to our advantage here in a second. So, looking at our bigger triangle now, we just figured out that this bottom part is the square root of 3,136. And we have the hypotenuse of 70. And if we go back to our original question, what is SU? SU is now the missing leg that we're trying to find. So looking at this red triangle, we're looking at, once again, A squared plus B squared equals C squared. We don't know, we'll call this B so we don't get confused with using A over here. So A squared is the square root of 3,136, but we need to square that. And we have B squared equals 70 squared. Now this is why I said we're going to leave this as a square root of 3,136 because the square root and the square cancel each other out. So if I took the square root of 3,136 and I squared it, I would just get 3,136 plus b squared, and 70 squared, 7 times 7 is 49. We got 2 zeros is 4,900. And then we're going to go ahead and subtract 3,136 from both sides here. So we take 4,900 minus 3,136, and that will figure out what our b squared is. So that's 1,764. And now we're going to go ahead and we're going to take the square root of that answer. And if we go back and look at our directions, it says to the nearest whole number, but this actually happens to be a perfect square in itself. So there's no rounding necessary. So our answer here is going to be just 42. And now we're at the last problem. We like to save the best for last, and most of you know when I say best, I usually mean the most challenging and difficult. And this one, it says a triangular pyramid is formed from 3 right triangles as shown below, and using information given in the figure to find BD. All right, so the 3 right triangles that they're talking about, we've got this one right here. We've got the one right next to it, and the one on the bottom. And none of the angles look like right angles because of this perspective that we're looking at, this 3-dimensional drawing being represented on a 2-dimensional space. But the fact that they tell us that they are right triangles, and we have the little square boxes down in the corner here, means that we can go ahead and assume that these are right triangles. Now the issue with this particular problem in finding BD is a part of this right triangle, but we only have one side, so we can't use that information at first to figure out what BD is. BD is also part of this right triangle, but once again you only see that we have one side, and we need at least 2 of those sides in order to find BD. So we can't start with either of those. But if you look at the bottom right triangle, we do have 2 sides. All right, we've got 35 and we've got 21. Looking for that right angle again, we know that 21 is a leg and 35 is the hypotenuse. All right, so we are missing a leg for this particular problem. So let's go ahead and start here. So we're going to look at a squared. We're going to call this side over here a, plus 21 squared equals 35 squared. All right, 21 squared gives us 441. 35 squared is 1,225. We're going to go ahead and subtract this. I'm going to move a little bit quicker because we've done this a time or two at this point. One thing that I want to mention from earlier in the video, at this last point where we take the square root of 784, I recommended in the last video to leave it as a square root of 784 because later on we would be squaring it anyway. If you do have a perfect square, and the last problem was a perfect square, this one ends up being a perfect square as well. We end up getting 28. If you get a perfect square, go ahead and take the square root of it. You don't need to leave it as the radical form of it. That's useful when it is a non-perfect square, but I didn't have a non-perfect square example to show you at the time, so that's why I decided to use that for that example. So we find out that a is 28 here, so instead of a over here, we're going to put 28 in there. All right, and with this one, now going back to BD, we have 2 sides to this particular right triangle. So now we can successfully find BD here. Another missing leg problem, but no big deal. We've done that plenty of times. I'm going to go ahead and use b for this one so we don't get it confused with the other problem that we were dealing with. So 28 squared plus b squared equals 53 squared. We already know 28 squared is 784. All right, so that's why it was kind of useful to just leave it as a square root, but no big deal. All right, we get 2,809 for 53 squared, and we go ahead and subtract that 784, just following our rules for algebra. End up with 2,025, and last but not least, we're going to take the square root of that answer, giving us 45. So that side that we are looking for, BD, ends up being 45. The question says round to the nearest whole number if you need to. There's no need in this case, so we just have 45 for BD. Your ALEKS assignment is going to be called Advanced Pythagorean Theorem. I abbreviated it to only 5 questions because there is no school on Friday because of the Easter holiday. Also, because of that, going to make it available early. It'll be Wednesday morning at the latest. I might be able to get it out Tuesday night. We'll see. But from my family to yours, I hope everybody has a safe, healthy, and happy Easter, and we'll see you Monday.